I'm going to talk really about some semi-basic things and some things that aren't so basic in the context of just what we need for efficient crop production for corn and soybeans. And I'll focus, some of you may or may not be aware that, essentially in the end of 2014, beginning of 2015, we set out in terms of giving a comprehensive overview or assessment of our fertilizer recognition tri-states. And so I'm going to talk a little bit about that work and just kind of what that, the implications for that, okay? I'm going to talk just a little bit about some of the P and K work that we've done. And it's going to include long-term trials and then these on-farm strip trials, okay? So, gosh, very briefly, I'm just going to mention 3 different trials that were started in 2006 before I got here, but Robert Mullen started these. We had 3 different rates of K fertilizer, P fertilizer, and a corn soybean rotation. And so just to show you a teeny bit of data from this, these are what we've got is our 3 trials in Northwest, Western, and Worcester, corn yields, soybean yields on bottom, and then our 3 fertilizer rates of 0, 1x, which is crop removal, and then 2 to 3x, which is double to triple crop removal rates, okay? And I show this because these red sites, these red dots, really literally have not received any phosphorus fertilizer across this. Here, this is the first 13 years of the study, okay? And we can see with some sites that that there is some trends in terms of seeing kind of consistent decreases with the unfertilized treatment. But for the most part, when we start in what we would consider the optimal or the maintenance range, the soils have capacity to supply fertilizer need for many years here, okay? So this is phosphorus trends. And then we can look at potassium as well. There are different graphs and different data. And here, interestingly, with this Western site, this is a Kokomo and Brookston silt loam CECs. This is in Clark County. CECs around, say, somewhere between 14 to 16, 17 CEC. These soils happen to be more responsive to potassium fertilizer. And we're seeing really, out of all these sites with P and K, consistent decreases with the unfertilized plots in soybeans primarily, but a little bit here in the latter years of corn. Now, again, this is essentially 9, 10, 8 years of not fertilizing at all and continually removing crop from those plots. And so, yeah, we would expect after that amount of time and the soil's drawing down that we're going to start seeing yield responses. But I like to show these data and this is just a kind of a real general kind of overview of it, just to show that, soils are capable when they're managed in that maintenance range of supplying nutrients for years, honestly, and because there's a reason for that, because soils are buffered and they change slowly over time, right? That's what we mean by buffering capacity. This idea that crops need to be spoon-fed and you need to put out nutrients and do foliar fertilization, we just really, it's not that we don't have any credence or stock in that. We think that when those types of practices make economic sense, it's in the minority of observations. We really don't see very, very little of that coming out in any of the data that we collect kind of from the collective piece of that. So again, when we are in maintenance range, soils have a capacity to provide nutrition to the crops for many years, okay, without fertilization. So there's a lot to be said of this data, and it's a lot of work. Randomized replicated strip trials, and here we're just taking big averages across all the trials. So across 54 corn trials, fertilizing ahead of time with phosphorus increased our average bushel per acre about 3.5 bushels, fertilizing with phosphorus. And this was primarily about, typically, not always, but typically say 100 pounds of P2O5 that was applied spring broadcast. Okay, it's often what was happening. There was some that was put through the planter. There a lot of different variability in terms of how things were done. Some, of course, was fall applied, et cetera. But it ranged across all these 54 trials from, we got a minus 20 bushel decrease to a plus 22 bushel increase, okay? And if we take this relative yield, which is just the ratio of fertilized versus unfertilized, it represented about a 2% decrease, a 98 relative yield, which is about a 2% decrease if we did not fertilize, okay? With soybeans, proportionally, it was about the same. It was a 1.3 bushel increase across all trials, and there's our range. Again, if we fertilized versus not, we had about a 2% decrease without the fertilization that occurred, okay? So really not huge responses in general to this, okay? And so then, and here there was some interesting things, maybe a little bit more interesting that came out. And one is that when we, fertilized with K, we got an average of about 4 bushel increase with K fertilization. But the range here in terms of magnitude of the increase was much greater. And that's what we've seen typically, that K, you can see really big differences. With phosphorus, they're not so dramatic. And so at one of our sites, we had a almost 60 bushel increase with K fertilization, okay? And then interestingly, and we're still trying to work some of this out, but for soybeans, we had 48 soybean trials. And across all those trials, applying K fertilizer decreased yields about a half a bushel. And this is kind of interesting work that's taken place in a few other states. Minnesota is one of them, where they're seeing fairly subtle but consistent decreases in soybeans following potassium, spring applied potassium. And there's some thought, I mean, we don't really know a whole lot about this, but this is also shown in some of our long-term data. I didn't show any of that, but I could revisit that and just say that we're seeing some detrimental effects with, certainly we need KCl fertilizer, but with that, the thought is that soybeans are a little bit sensitive to the chloride and that salt in the potash fertilizer. And so we've seen an overall, an average decrease in K, okay? Sorry, in an average decrease in yields based on K fertilization, okay? But again, the range here is much, much smaller than we saw with corn. All right, so what does that mean? Well, that means that a couple of take-home points here. One is that soils are highly buffered and they can provide fertility needs, over multiple growing seasons if required. And the second thing is that these on-farm trials across a whole diversity of different sites really underscore that when soils are in those recommended ranges, the chances of seeing yield responses are not very good, and the chances of seeing a really significant yield response is very low. This, as an example, this nearly 60 bushel increase occurred in a field with a malic potassium of about 60. So it was very, very low in K. And because of that, not surprisingly, we see a large response with fertilization. In some sense, this talk, I'm not spending a lot of time trying to convince you of exactly how we got the information, but I can just say that this is all a very data-driven exercise, and we conducted, literally hundreds of trials. And so these are our new recommendations in terms of malic. So 20 to 40 pounds part per million for malic P if you're growing corn and bean. If you have wheat or alfalfa in the rotation, that slides it up. We've confirmed that wheat and alfalfa need greater phosphorus requirements, especially when they're growing in those cooler soils with low P mineralization rates. Another kind of bit of a major change that we did is that instead of scaling our critical value based on CEC, which was done at kind of a continuous scale, we've just simplified this because we did not find any justification for that. So we have sandy soils less than 5 milliequivalent per 100 grams CEC, 100 to 130, that's our optimal range for those soils. And for basically all others, 120 to 170 part per million. These are in part per million. If you multiply these numbers by 2, you essentially get the pound per acre equivalent, okay? So we did a bunch of work with grain nutrient removal rates. I'm gonna skip over this. The main take home here is that between our 1995 tri-state and our new data, which was based on literally thousands of observations, we see pretty remarkable decreases in grain nutrient concentration, and particularly with potassium. So that's an important finding, means that for every bushel that is being removed from a field, there's actually less K2O in that than there was, say, 25, 30 years ago. And so that has implications for what we're fertilizing, okay? And our recommendations have been updated based on that. And then I'll just talk about, because it's an interest a lot of folks, a lot of chatter about sulfur. And we've are kind of on the tail ends of compiling a bunch of trial information. We've got whatever this adds up to be, relatively around 100 different trials, again, mostly on farm replicated trials in corn, bean, and wheat that we've conducted as a OSU extension over the last, say, I think the first trial here is in 2013, so close to 10 years. And we just don't see a lot of, we can see at all these trials that we've added sulfur. We see some increases, a little bit of in-furrow burning with thiosulfate, too much salt, or even as a starter. And we just are not seeing a lot of observations. So there's a lot of chatter, a lot of interest in sulfur. We just, in our trials that we've conducted, haven't seen it. We can compare that with some work in Indiana in looking at early planted crops, especially soybeans, being more likely to be responsive than, say, what would be considered quote unquote normal planted, whatever that means these days. But sometime, say in May, most of these, late April, early May, these trials would have been planted typically. All right, so to summarize our recommendations, most things have been updated. Corn nitrogen rates, our framework, our extractant, but in some ways things are different, in some ways they're not so much. So our P and K critical levels in the framework really is mostly the same. It's now based on Malic 3, okay? So we've got good confidence, folks, in terms of the numbers that we've put out and the work that we've done. It's a tremendous amount of effort. A lot of this was on Ohio State University county educators and private crop consultants ran a lot of trials. And I think we've got a lot of great data to kind of stand behind the recommendations that we have. So I'm just going to end there.